Okay, so during this talk, what we are going to do is to try to share with you how you can use CARTO platform to extend the deck.gl capabilities. During these days, we have been seeing how you can use deck.gl, how you can use Kepler, but CARTO is also available if you have your data in your data warehouses, like BigQuery, Snowflake, Redshift, or Databricks, and you can create using different maps and different geospatial analysis. So we are going to try to demonstrate how you can get benefits of that and how you can perform this kind of analysis. So if you were familiar with the previous CARTO version allows you to upload data on a PostGIS, and then you can create map on the cloud. But the new version of CARTO is cloud native. And what that means is that instead of bringing your data to CARTO, what you bring is your connection to your data warehouses. And it has different improvements. One of the improvements is that we have direct connection to your data. So you don't need to create ETLs. You don't have any kind of security issues on that. The other thing is that the separation between computing and storage. If you are familiar with previous database like PostgreSQL, for example, if you want to have all the data there, you need to have you need to spend a lot of money in RAM or in SSDs. And right now, this compute separation, you only pay for the data in cloud storage. So then what you can do is that if you need to query the data, you only pay for the query that you are running. And that is very cost effective. If you have a data set, like for example, with transactions of MasterCard and you have like 2 terabytes of data and you only want to run analysis one day, you don't need to pay for this amount of disk and RAM. The other is that we strongly believe that the spatial SQL is the future for analytics in geo. And why we thought about this is because we think that we are seeing a lot of people starting doing analytics on geo, but they are blocked because they are not developers. But they want to continue doing this analysis using SQL. Another great advantage of this is the data multi-tenancy. So imagine that you have in an organization and you want to share one data set with another one, you can just share on the cloud because the data is available there. And you can just use joins using your data with the external data. So you don't need to create APIs to synchronize data. You don't need to maintain all of these things. And the data is always fresh. So I'm going to start right now with a demo. Now I think that is fine, if you can hear me. If not, this one, I'm going to try to go here to connections in CARTO. But if you go to connection, the first thing that you need to go to do in CARTO is to bring your own connection that you can connect to your BigQuery, to your Databricks, Postgres, Redshift, or Snowflake. Once you have the data there, you can go directly to the Data Explorer in CARTO, and you can try to explore the data that you have inside of your data warehouse. In this case, we are going to try to open a demo table. Like, for example, I want to visualize one thing that is like the POIs from the United States. And here, just you have the option of creating a map, and it will open one thing that is Builder. What is Builder? Builder is an extension that CARTO has been working on Kepler. That is based on Kepler, but we have added a couple of things to it. One of the things is just change a little bit the UI and creating different things to allow you to scale based on the data that is on the backend. So in this case, I have a data set of POIs that is all the POIs of the United States. It's not so big. It's like 1.5 million of rows. You can, for example, decide that you want to color the map based on the type of POI. In this case, what we are doing is just going to the backend, but another thing that we have improved here in CARTO is to allow the user to add some widgets. In this case, what we are going to do, for example, is to count based on a category. We are going to count based on the type of widget that we have. We select this, and we have been able to create this widget. Before, we have seen a library that was called Nebula.gl, and we are using this. For example, you can here draw a polygon, and using the max filter that we have in deck.gl, you are able. I'm not sharing. I'm sharing the other screen then. Wait, one sec. Yeah, I think that I'm sharing the other one. Now it works? Can you check? Yeah, sorry about that. I connected the other screen later. So in this case, what we are doing is to filter in the data based on that max. And the filtering can also happen if you click here on the max and you move this around, you can see how fast the data of the widgets are also updated. So it's something that we have added to Kepler. Another thing is that we have been able to create, for example, custom legends. We have improved here the legends for the different kind of layers, or like points, choropleth, and so on. Oh, I lost it's here. I lost the mouse. And on the iterations, another thing that you can do is to create here different tooltips. In this case, what I'm going to do is to add the name, but I think, for example, this another field is the name, and you can have all the data here. Okay, that is like the regular things that we have for visualization, but we have also a really good improvement that we have done regarding a spatial index. So imagine that you have a data set that is like 600 million rows using spatial indices. And we are going to show how you can visualize directly out of the box with CARTO. You don't need to do anything else. Just you can go here to the CARTO backend. And I have here one subscription for data observatory. Let's check here. Here we go. And this is a data set that if we go here is like 600 million rows and 18 gigabytes of data. And we are visualizing this directly from the database. You can go here. I'm going to move to New York, for example. And then you can create different, you can style. For example, I'm going to style based on female population, for example. And we have this on the data. Now, what we can do also is to create a 3D map, as we are going to add some age, and we are going to add another attribute using age. For example, like male population in this case. This is getting some stats from the backend, and then we can just visualize this. Let me check here. I'm going to change the scale. This, and we have this kind of beautiful maps. In this case, if we go here, like you can check here, we are visualizing a data set in real time of 600 million points. And that was pretty fast because of the things that offer the data warehouses, that they are super fast using spatial indices. So here we are not using geometries at all. What we are using is just number, and these databases are incredibly fast to visualize this kind of data sets. And the cool thing is not only useful for, it's not only useful for visualization. The other thing, yeah, exactly. Yeah. For this kind of layers, what you can do on the backend side, and Felix is going to show that later on deck.gl, we have a special layer that you can say, hey, this is my H3 dataset, and I can use an SQL expression to define how I want to aggregate that. So once you move around the thumb up and down, you are aggregating this data using just an expression in SQL. And that is really powerful for that. But that is not only useful for visualization. And that is what I would like to talk about here. That is how can change this kind of analysis that we do in regular geo and using the classes to something that we use using spatial indices. So right now, I'm going to try to present how we can do two analyses. One is a coverage analysis that is try to count how many people live less than 5 minutes walking from a pharmacy. And the other is check, do we have too many pharmacies? Do we have some kind of overlap between them? The first thing is that What you want is to create an area of interest after your pharmacies. So we take the data from OpenStreetMap, the first one that we have available there, and another one thing that you can do using CARTO platform is create ASO lines. And how we do that? We use right here, we are using data from external services. So you can create an ISO line calling TomTom provider or here providers. We use here inside of the database external function that can call external provider. So in this case, what we are doing is taking a table from BigQuery, saying that I want to create this other table, checking that the geometry of the point is this column, and I want to know people that are 15 minutes away walking. Then how we can do this in coverage? If we look at the classical approach, you can check that it's very expensive in terms of calculations. That the first thing that we need to do is an union between all the geometries. And it's not easy at all. If we need to run an union on all the geometries, that would be quite expensive. If we have a lot of isochrons that they are overlapping together because they are in the same area. And then the next thing is to run an enrichment process to get the data from the population. And you need to do their intersection of geometry, you need to do interpolation based on area, and then you run the actual coverage that you have. The first thing for overlap, you need to do a cross-join intersection between all the polygons that you have. And then once you have the cross intersection, you also need to run the enrichment. So that is quite expensive. We have projects that we have done with this classic approach, and these are. But how this problem can be done is just try to convert this in a raster problem. And how do we do raster problem inside of a database? It could be done using spatial indices. So what the first thing that we do is to convert the geometries into numeric things. And how do we do that? We create a polyfill using S3. So basically what we do is to convert this geometry using this function. CARTO provides another thing that is the CARTO analytic toolbox that inside of BigQuery, you can just run aggregations using or different function of S3. In this case, we are running just a polyfill at the zoom level 8. I decided to use zoom level 8 because of the data that they are using is one zoom that fits properly well. And using this, that is a query that's run in less than 1 minute. You can get the data and you can get the polyfill of the geometries. If we go here, let me show it to you. We're here. If we go to maps, and let's open the pharmacies, and we can visualize here. The first thing is to visualize the ISO lines. So imagine that you need to run an union on these geometries. Imagine that you need to run an intersection with all of these geometries. It's a huge computing thing. And if you grow on the chain of points, it's not scalable at all. And this is what we have when we have a polyfill. We have just polygons that they are just numbers. So you don't have operations with geo for that. So if we continue and let's see how we can do a coverage. It's just as simple as this. It's just as simple like try to remove duplicate of your table because you only need to know only one single grid. You don't need, if you have 10 grids, it doesn't matter for the coverage. I just want to count how many grids do I have in the areas that I have an isochron. And it's all it is. So imagine that the next thing is that you want to get one data set for population. We have CARTO Data Observatory that you can go there and create and find a proper data set that is available. We have there more than 10,000 data sets available for just to use. We can see how easy it is now an enrichment, just a simple join in the database. You only need to join using grid. And this is the final analysis for coverage. That the first thing that you do is to calculate coverage by removing duplicated. And the other, for population, you just run a join with the S3 IDs. And for overlap, it's also quite simple. The thing that you need to do in this case is count how many overlap do you have, how many H2 grids you have repeated in the same area. And that can be done just using a group by and counting the number of columns that have more than one grid. So that's mean that in these areas, you have two grids that come from two different pharmacies. So it's like an overlap. So that means that in that specific area, an overlap is happening. And then again, the enrichment, when you have the data, the enrichment is so easy like a simple join. These queries that run on analysis of overlap and coverage, taking this query less than 1 minute. I think that is like 25 seconds. And then let me show to you this final map in Builder with this analysis that we are visualizing on one part, the coverage. Here is the coverage that we have with pharmacies less than 5 minutes working in the whole United States. And on the right side, you have the overlap. We have two widgets that tell you what is the total coverage that you have and the total overlap in population affected here. And I think that is pretty interesting how you can do this on the data warehouses, how you can convert this regular problem using geometries into, especially in the things that you can scale for analysis, for data visualization, and so on. And now with Felix, we are going to see how it can be integrated with deck.gl.
Thank you. Yeah, so that was more the kind of back-end side of things. I just wanted to talk a bit about how we take this data and actually go about visualizing it. So we have a lot of different types of users. Some of them don't even really know what JavaScript is. Some of them are experts in programming. So we have different ways of letting users access and export this data. So one you've already seen is working with Builder, where everything is interactive. And as you kind of go down with each step of kind of technical complexity, then you get more freedom, but you have to do more work. So the first one we have is basically an iframe that contains Builder, which is what Alberto was showing, but without any of the interactivity. Then we have something called fetch map, which lets you export the layers that you have within Builder with all of the styling that's been defined there as deck objects. So this is now becoming more like a programmatic interface. Then we have CARTO layer, which is operating purely on the data level. So this lets you just say, I have this data set, I want to visualize it, and then I want to write and program around it. And then finally, we just basically have a wrapper for the API, which is just fetch layer data, which just does the GET request for you. So just to give these as examples, then the first one here is the public map. So this looks basically the same as what Alberto was showing. And what's nice about this one is that the widgets stay here, and we can do the same thing with like a lasso tool. This one. The next one is using something like fetch map. So this is like the easiest way of getting a visualization that someone has designed in Builder, which is actually quite a nice workflow where you're working with like a designer who kind of selects all the colors. Yeah, thanks for closing that window. And we actually use this to make something like this visualization when we're working with Google, where it was like a collaboration with a lot of different teams. But what was really great is I could work with Hattori, our resident, very patient cartographer who had very specific ideas about every kind of color and everything that we wanted to do in every slide. And he could work on the slides that we have here in Builder. And I could then inject them into this visualization by just referencing this whole collection of layers, where I basically just have to maintain a set of map IDs and add the bits that I want to add. So here I added the kind of transitions, the animations, but I didn't have to worry. You might recognize this, Ilya. I didn't have to worry about matching the colors that we have in Builder to my code. So this is basically what it looks like. It's an API that's designed to try and be as simple as possible for the user. So you basically extract the map ID that is in the URL and you pass it to deck.gl, and this is all the code that you need. So it's really great for doing like just demos with JS Fiddle if you wanted to show a customer quickly how to embed something. The next step down is something called CARTO layer. This is more if you're actually building an application and you want to have like a good connection to some data in your database. So here you get more flexibility. You're closer to deck.gl. What you lose is this magic transition of all the kind of layer styles from Builder. So this isn't so much for doing like demos. It's more for building an application. And it's basically a wrapper around the layers that we're using within deck.gl. So rather than supplying your data as GeoJSON or something like that, you're referencing a table within CARTO. And this lets you do quite a lot of interesting things, as we were saying with the aggregation before. You can put a SQL query into your aggregation expression and change what data is being sent by the server in real time, basically. And just to mention, then this is all kind of powered underneath the hood by a function called fetch layer data, which is kind of like the CARTO layer, but without the layer. I don't have a demo for this because it's not so interesting. One thing I wanted to just pull out, because it's quite a nice demo, is when you have a SQL expression, we have this feature called parameterized queries. It all looks different than on my computer, where not only are you able to supply a query, but you can supply parameters to that query. I can't quite see this here. Yep, so I can define this query, but rather than it being static, I can specify 2 question marks and then pass these as query parameters. So what this lets me do is have a user interface where as I change the range, then it's going to send a different query to the CARTO data warehouse, execute the query, and give me new data based on a different time filter. How are we doing for time? We still have time, right? Yeah. Okay, I wanted to talk a bit about one of the features that we implemented underneath the hood to make this work, which people might not be aware of, and that is the ability with the tile layer to have a custom tile set class. So in the past, the only way of working with a tile layer was using the standard web tiling scheme that you use in kind of all different types of maps. But because we wanted to implement a different tiling scheme for spatial indices, both quad keys and H3 indices, we extended this to provide like a new system of tiling. So this demo here is just showing the standard quad key, is that right? Yeah, standard quad key tiling scheme. Which is a spatial index, which is basically exactly the same as the tiles you have when you're using a web map. So here I can load in data in this format here, where each quad key here is corresponding to a tile. And the way that I'm just going to skip this, this is maybe not quite relevant. Yeah, so basically, the normal way of doing this is if you have a tile layer, you specify your data as this template string, and deck.gl is going to assume that you use X, Y, and Z to specify which tile you're using. What we did in extending this was giving the user the ability to specify their own tile set class, which encapsulates the logic of a different tiling scheme. So whereas before all of our tiles were being referenced by an X, Y, and Z, we can also reference them using this quad key scheme, which has been used in Bing Maps, but we also use it internally. And if you notice, then rather than our data attribute being a template string which uses X, Y, and Z, we here just use I, which is just an individual index. And then deck.gl is just going to do everything in the same way as before. So this example is a bit of a toy because the tiles are the same. You know, it's the same shape, but you can then use the same idea to do something else with H3. So first of all, I'll just show how this specific tileset class is implemented. Hopefully you can, is this too small, this text? Shall I make it a bit bigger? Yeah. So making one of these tileset classes is actually very simple. You just have to give deck a few bits of information on the interface. So you have to say, if I have a given viewport, then what tiles, what indices are in that viewport. You have to explain how you want to convert an index into a string. And you need to say what zoom level of these tiles you're at, so it can construct the tree. And then this is using this parent index. So it's actually quite an abstract interface. You just describe how these tiles relate to each other, and then the tile layer is going to go and do all the tile fetching and visualization for you. So the main reason we were doing this and actually designing this new abstract class was so we could visualize H3. So this has got a completely different shape of tiles across the world. But what is nice is that we can use exactly the same abstraction as we had with quad keys, even though the shape of them is completely different and the hexagons have got a different shape depending on where you are in the world. And rather than like doing all these computations ourselves, we can use the H3 library, which pretty much just gives us all we need. So we can just say, this is my my viewport and pass through some kind of like bounding box. And the H3 library is going to just compute this for us. And the same goes for the resolution and getting the parent index. Yeah, I think that's basically everything. I don't need to see the rest of these slides. This was something that was more internal. So yeah, I would say that's full. We got any questions?
I would like to first try to visualize another data set that is quite huge, I think. I think that we have a workspace here, and we are going to try to visualize a data set that is near 1 billion rows. With thing that we have this here. Let's check. United States. No. No, it's here. It's inside public. And this one is United States is a quad grid. And here you can check that is almost 1 billion rows, 900 billion rows. You have checked how this is creating. Let's try to create a map around this. Let's go to New York again. Yeah, here we go. You can define here, like for example, in this case, the styling that is going to ask for the backend, which are the ranges that we want to use. In this case, we're going to use the zoom. He's trying to get the buckets where we have the breaks. And when we have that, I think that we will be fine. It's loading, and yeah, here it is. And if you want to know that is no cache, I can go to any other place. That if you want to tell me one place, I can go. Let's say Chicago, for example. And here it is. One data set that is almost 1 billion rows. Okay, so I don't know if you have any other question that you want to share with us.
I wonder whether you have touched the Google S2 as well, and if you have any experience with indexing beyond the hexagons with H3 and the traditional quad 3.
We decided to go with these two, with H3 and quad being just a simplification in our product. Because it's like, and why we are using both, I think that H3 is the most popular one, and it's probably because of the property that I see is what fits better in almost all the analysis. But for others, especially for visualization purpose, we also need to maintain the quad bin because they want to have like a grid that is based on squares. Yeah, I think that we didn't enter in S2 because just a simplification on the product.
Yeah, we didn't try it, but deck.gl can visualize an S2 layer. So it should just be a matter of constructing this kind of tileset class in exactly the same way. Yeah.
Also, another important point that I forgot to mention is how we do this in a cost-effective way. Because you can imagine that, hey, you are visualizing a data set of 1 million or 1 billion rows, but how expensive is that in BigQuery? Because BigQuery will charge you for all the computing that you are doing. But what we have done is to create one specific cluster, and the codification that we use based on S3 lets you to use range queries. So in all of these databases, you have the opportunity to create cluster of the data. So when you are going for a tile, you don't need to scan the full data set. You only need to scan the data that is inside of your tile. So the query in BigQuery is super cheap because you only need to ask for that. But if you do zoom out and you don't limit the zoom, in that cases, you are going to explore the data set. So the lower the zoom level, the more data that you need to fetch from the database. But if you control more or less the way, is using a very effective way to save money and also time on computing. And it's, all the data warehouse have a similar things. Resi have shortcuts, Google BigQuery have clusters, Databricks have data orders.
And how do you decide, like, how do you split the dataset, partition the dataset into clusters? Do you use the zoom, like just a tile on a specific zoom level?
Just a cluster on the grid. Right now we only support one level of H3 for dataset. We don't support a dataset with multiple level of H3 or quad bin. What we do is to just cluster based on the H3 or the quad bin, because already the codification that we have done for the numbers allow you to do that inside of the database. Also, on top of that, these databases added something that is a cache on top of that to avoid to go to the cloud storage. In the case of Google, you have something that is called BI engine, and in Snowflake, you have the acceleration engine. In Databricks, you have Photon. So all of them have this kind of thing. So in a lot of cases, when you have the data already there, you don't need to go to the cloud storage to feed the data into your cluster for the calculation.